Hello everybody, we are team number 25027 and our project is the new cart and connector design for the SynCardia Total Artificial Heart Hospital Driver Unit. And let's take a quick look at the poster we'll be bringing to Design Day. Here's a quick look at our poster for Design Day. It has our project overview, our goals and project scope, the results and deliverables, our materials and methods, and as well as a conclusion and future steps for our sponsor. We'll get into detail about these subjects later in the video. Hi, I'm Zach. I'm the team lead for this year's project. Our team collaborated with SynCardia, a Tucson-based company known for developing the world's only FDA-approved total artificial heart. This life-saving device is used to bridge patients to transplant when both ventricles of the heart fail. Here, you can see the total artificial heart implanted in a mannequin, the actual device that gives patients a second chance at life. This implantable heart is powered by this Companion 2 or C2 driver. The touchscreen on this device allows clinicians to adjust different pressure and vacuum settings to tailor the heart to that specific patient's needs. This C2 driver can be docked into the hospital cart while the patient is still in the hospital. This hospital cart charges and powers the C2 driver while providing easy transport of this entire system while the patient is still in the hospital setting. Now let's talk about what our project actually is, which is a redesign of the hospital cart. The hospital cart requires modernization due to component obsolescence. There are two key components on this hospital cart that are becoming obsolete, those being the display screen and the power and data connector between the C2 driver and hospital cart itself. We are providing SynCardia with a comprehensive redesign of the entire hospital cart to not only address the component obsolescence, but to better meet patient needs. Included in this design package is not only the CAD model of the redesign, but manufacturing drawings for each component in the design so that production of these carts can start as soon as possible. On top of this comprehensive redesign, our team retrofitted replacement candidates of the connector and display screen onto an existing hospital cart. Manufacturing drawings for all components needed for this retrofit are also included, and the entire design process is documented through SynCardia's design control procedure. This allows for the obsolescence issues to be resolved sooner, as the production line of hospital carts is set to be interrupted by the end of this calendar year. Not only does the component obsolescence cause logistical issues, but it can leave patients without the life-saving devices that they need, and so it is imperative that we solve these problems. Now, let's meet the rest of the team and talk about the work that we did throughout the year. Going left from right here, we have Alexa, who's our electrical lead, Lynette, our biomedical lead, Siraj, our mechanical lead, me, our team lead, Matt, our management lead, and Chris, our procurement lead.
Our objectives were to replace the obsolete connectors and display screen with new candidates onto an existing hospital cart. This will extend the lifespan of the current hospital cart fleet. Our team will provide a cost analysis to inform SynCardia of the financial commitment required to enact these changes. We will document these design changes through SynCardia's design control procedure. This paperwork is referred to as the quality system documentation. We will also provide a complete redesign of the hospital cart.
Let's go over some of our system requirements. For a retrofit kit system, a key requirement is the hospital cart display shall provide all the functionality provided by the Companion 2 driver display. Additionally, for our next-gen system requirements, two of the key requirements are the hospital cart shall be designed so that the Companion 2 driver can be removed and inserted when lifted less than or equal to 20 inches from resting position in the cart. Additionally, the hospital cart shall be able to traverse a 2-inch gap when pushed at any point.
Now let's take a look at the methods we used to create our next-gen model. The next-gen hospital cart was completely redesigned in SolidWorks with over 200 components. Certain features of the current model of hospital carts remain the same, while key new features were added to fulfill our design requirements. And simulation studies were done to verify certain requirements such as the handle load requirement seen at the bottom of the screen.
The new display screen integrates into the existing hospital cart using the same data cable as the old screen and a modified converter cable from the old screen as well. The new connector is larger than the old connector, so we modified the housing part for the connector on the hospital cart and the C2 driver to fit our connector. The old obsolete connector has an 8x5 configuration of data pins, while the new connector has an 8x4 configuration of data pins. Both connectors use the same exact pins, so we reconfigured the pins from the old connector to the new connector.
All right, now let's get into our next-gen design concept. And as you can see, we made a number of improvements. Namely, we have replaced our obsolete components, our connector and our screen, with currently market available products. Along with that, we have made several quality of life improvements, such as a soft touch handle concept, a flipped orientation power plug, and greater diameter 6-inch wheels to be able to traverse elevator gaps in hospitals. Looking at the rear, we've improved our screen mobility, added storage hooks, created a sturdy back support with a less empty space in our overall form factor, added a battery storage compartment, and allowed easier access to our C2 driver and exposed its air filter for easy maintenance.
For requirement verification, we are following the existing documentation that SynCardia has that outlines their verification and validation procedures. We will be using this to determine our own verification procedures for our 31 requirements. The verification status is documented in our internal systems requirements verification matrix.
And now let's take a look at some of the key results of our retrofit kit and next-gen model. The new connectors and LCD module have been successfully integrated onto an existing hospital cart, and the connectors have passed the life cycle testing by not showing any degradation after 52 docking cycles. And the next-gen handles have deformed less than 1 millimeter under 2 times the required load. Here's a demonstration of our project working. Here we have our hospital cart with the C2 driver docked into it that's attached to an artificial heart which is pumping on a mock tank right now. We can see the information is mirrored properly. When we change the screen on the driver, it's mirrored on the hospital cart there, and everything's functioning properly. So for our deliverables for this project, we have delivered our testing components, phases 1 and 2 of the quality system documentation, and a full technical data package with our CAD models and drawings for the new cart design. The next steps for our sponsor would be to complete the V&V process and then transition to production after they finalize their budget and manufacturing strategy.
We have a few standards in safety that are relevant to our project, but a few of the key ones are IEC 60601, medical electrical equipment with subcategories 1-1, 1-2, and 1-8, along with ISO 13485, medical devices quality management systems, and ISO 14971, application of risk management to medical devices.
Throughout this project, we learned that outside supplier issues can cause delays, but with guidance from SynCardia, we adapted and delivered key elements of this project. The lessons that we learned throughout this project were to have contingency plans on top of risk mitigations and to maintain constant contact with our suppliers to keep our needs at the front of their mind. And finally, I'd like to thank the stakeholders at SynCardia, Steve, Duffy, Martine, Jose, Sid, Andrew, Mark, our mentor Pat, and the people at the EDC. We couldn't have done this without you.